Okay, this is the last one. It's the free response on the 3.3 to 3.5 review, number 10, and it allows calculator usage. And you will find that on the AP, when they give you a graph, or excuse me, they give you a function and a calculator, and they ask for you to graph, they're going to be very picky on the points. Because you have a calculator in hand, you should be able to get the picture off of what you see on your screen. So we're going to start off by going to our y equals, and we're going to graph the absolute value of the tangent of x. So remember, absolute value you can get out of your catalog. And right now I'm not at my a's, so rather than arrowing up really fast or for a long time, I'm just going to locate the button that has an A above it, which in this case is my equal sign. So I'm going to hit my equal sign. It pops me up to the A's, and we can see that absolute value right there. So I select the absolute value, and inside that I need the tangent. So just like on my 84s, the tangents and cosines, all that trig stuff is right here. So I'm going to access it using my blue button and the T. So there's my tangent, and inside I just need an X. Remember, on this calculator you have to close every parenthesis you open. So we close the tangent, close the absolute value, check our pretty print, that's what it's supposed to be. Now let's go to our window. Notice that this is negative pi over 2 to positive pi over 2. So to graph f, I'm going to go to my window. So that's diamond window, diamond F2. And I'm going to make my x go from negative pi over 2 to positive pi over 2. Then I'm going to look at my screen, my picture here, and it looks like my y's go from negative 4 to 4. So I'm going to do the same thing here with my y's. I'm going to go from negative 4 to 4. Then I'm going to hit my graph, so that's diamond F3, and I'm going to look at my picture. So that's what I need to draw on my graph. So some of you might kind of ignore this stuff. So what I want you to be able to put on this picture is the exact output when I plug in the pi over 4s. These are exact values, so you should be able to get them off your unit circle, or what you know about tangent. So tangent of pi over 4 is actually 1, so the absolute value of that is also 1. Tangent of negative pi over 4 is 1. So those 2 points are nice and pretty. I've got to be able to see them. Anything that's an exact value, we should be able to see on the picture. So pi over 2, if you recall, that's where we have the asymptotes for tangents. So you better not be going past that asymptote. Just be getting close. So this would earn the 2 points. 1 point for the right side, 1 point for the left side. Okay, part B now is we want H to be G composed with F, and then write an expression for H. So if we come back up here, H is G composed with F, which means I'm going to plug F, which is that absolute value of tangent of X, into G. And G will actually take whatever's inside it and raise it to the 6th power. So that will be the absolute value of tangent raised to the 6th power. Now you'll notice on here that we have some redundant notation. Absolute value will make everything positive that comes out of the tangent graph. But raising to the 6th power will do the exact same thing. So we don't really need both. We could just write the tangent of x raised to the 6th power. And this will actually be an easier version to work with when we move on to the next parts of the problem. So I would recommend on the test that if you can simplify the absolute value raised to an even power, that you do so, that you get rid of that absolute value. Otherwise you'll have a piecewise function that can get kind of messy. Part C says we want to find the domain and the range. So that means we got to think about what causes problems for tangent. Well, if we think about what causes problems for tangent, and we keep in mind the domain that was given to us, the domain of the composed function cannot be any larger than the domain of any interior function. So because f was inside G, we don't get to use all real x's. We only get to use the x's that came from f. So the domain for h is going to be the same as the domain for f, which is negative pi over 2 to pi over 2, and we cannot include those because they weren't included on the original. The range will be all the y values that come out of h. So if we think about tangent to the 6th, those are all positive values. Can tangent ever be 0? Absolutely. Can tangent get infinitely large? Absolutely. Can tangent be negative if we raise it to the 6th power? No. So that means my range will start at 0 and include it, and then climb as high as it wants. Points for that, you get 1 point for the domain, and you get 1 point for the range, 0 to infinity, and then you're going to get another point for not including the infinity and for including the 0. So you could have also have written this as y is greater than or equal to 0, or you could have written it as hard bracket 0 up to infinity with a soft bracket. Any of those three would be full points. Okay, last part. And I don't know if I can fit this here. Last part says we want to find an equation of the line that is tangent to the graph of h at the point where x equals pi over 4. So we need an equation of a tangent line. That means we need a point and we need a slope. The point, we know the x-coordinate is pi over 4, and the slope is going to come from the derivative of h evaluated at the point of tangency. So first let's find the y-coordinate. The y-coordinate means we're going to take this pi over 4 and plug it into h, which we found in part B. So if I plug a pi over 4 in here, the tangent of pi over 4 is a 1. 1 raised to the 6th power is still a 1. So I've got my point. Now I need my slope. Before I can plug pi over 4 into the derivative of h, I actually need to know what the derivative of h is. So h prime, I'm going to use the chain rule. The first thing I hit is the 6, that power. So I'll bring the 6 down, leave the inside alone, and decrease the power by 1. So I've taken care of the power. The next thing I need to do is the derivative of the tangent. The derivative of the tangent is a secant squared of the inside unchanged. And last, I would take the derivative of the inside, which is just a 1. So here's h prime of x. I need h prime of pi over 4. So I'm going to plug a pi over 4 into this. I'll get a 6 times. The tangent of pi over 4 is a 1. Raised to the 5th is still a 1. And then I need a secant squared of pi over 4. So if I think about my unit circle, pi over 4 is right here. The cosine is a root 2 over 2. That's the x-coordinate that goes with that point on the unit circle. And the secant is the reciprocal of this. So that would be a 2 over a root 2. And when I square it, I'll get a 4 over a 2, or a 2. So simplify that, you end up with a slope of 12. So now that I've got the point and I've got the slope, I can write the equation of the line, which is y equals the slope times x minus the x-coordinate plus the y-coordinate. And I'm done.